Welcome to the third part of our chapter, Euclid's Geometry. After Euclid stated his postulates and axioms, he used them to prove other results. And the statements that were proved are called propositions or theorems. The statements that were proved are called propositions or theorems. Now let's see a theorem. Theorem. Two distinct lines cannot have more than one point in common. Two distinct lines cannot have more than one point in common. Well, that's obvious, though we have to prove that. Take two lines, L and M, and assume that these lines have 2 points in common. That is, the lines L and M passes through two distinct points. But remember the axiom we just learned. That is, given two distinct points, there is a unique line that passes through them. But here we got, that is, there are two lines passing through two distinct points, which is a contradiction. Hence our assumption was wrong. Therefore, two distinct lines cannot have more than one point in common. What was Euclid's fifth postulate? If a straight line falling on two straight lines make the interior angles on the side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on the side on which the sum of angles is less than two right angles. There are several equivalent versions of this postulate. One of them is Playfair's axiom, and it is stated as: for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. For every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. Let this be a line L. Let's choose a point now. Well, this is a point P. Through this point, we can draw various lines, like this. But look, here only one line is parallel to the line L. That's what this axiom says. This result can be stated in other way too. Like, two distinct intersecting lines cannot be parallel to the same line. Two distinct intersecting lines cannot be parallel to the same line. Now, let's prove that an equilateral triangle can be constructed on any given line segment. Let AB be the given line segment. By Euclid's postulate 3, we can draw a circle with any radius and any center. Now we have to draw a circle with radius AB and center A, like this. And now we have to draw another circle with radius AB and center B, like this.
India's #1 learning app, Columbus Learning App.
Columbus Learning. Discover new ways of learning. Kannur, Cochin.
Download now.